In our finance journey so far, we have encountered simple interest, compound interest, straight line depreciation, reducing balance depreciation, and then this nominal to effective conversion, because we are working with different periods of compound interest. And so in this video, we're going to combine some of these concepts into a more realistic approach to finance. So when it comes to financial maths, we don't often just put money in an investment and leave it there over time. We engage with it. Sometimes we are able to add, sometimes we need to take away. In a very realistic sense, the interest rate changes often, and so that's what timelines allow us to deal with. Let's look at some examples. So Melissa made a deposit of 25,000 Rand into an investment account that paid interest at 7.4% per annum compounded monthly. After 2 years, the interest rate changed to 7.9% per annum compounded quarterly. How much will this investment be worth after 7 years after the initial deposit was made? So the minute that I start to read a story like this, my brain jumps to timeline, because that's how I'm going to solve this question. So let's have a look at what Melissa is doing. At T0, that's the day she opens this investment account, she is adding 25,000 Rand into the account, okay, and it pays interest that we are going to come to 7.4% compounded monthly, and then after 2 years it's going to change to 7.9 compounded quarterly. So after 2 years the interest rate is going to change, and after 7 years we want to know how much is left. So definitely a nice and straightforward question. T7 will be the end of the day. Here we go. How much is in that account? And somewhere here at around about T2, the interest rate changes. So let's get that interest rate down. This part was 7.4% compounded monthly. So remember, I always say there are 12 months, and we're going to take the 100 there to the denominator so that we've got it in percentage. And then it's going to change for these last 5 years here. So 7.9% compounded quarterly, so 4 and the 100 for the percent. Okay, and so what I've already alluded to is we just need to work out the number of time periods. So from T0 to T2, that's 2 years. And from T2 all the way to T7, that's 5 years. And with that information, we are able to work this out. Okay, so this is a compound interest question. So A equals P, 1 plus I to the power of N. And now let's see how we can do it. If you can do these timeline questions in 1 year, in one step, I strongly encourage you to do that because it avoids rounding off and influencing the accuracy of our answers. But if you can't, that's okay too. Just remember to keep all of the decimal places. Okay, so Melissa initially invests 25,000 Rand. 1 plus. The interest rate there initially is 7.4% monthly. So there we have it. And we said that was 2 years, but remember that it's being compounded monthly. So 2 times 12. Okay, and now for the next part, what happens is everything that we've had up until this point in the account becomes the new present value. And so then we'll build on that and we'll say, okay, well now the interest rate is going to be slightly different. So 7.9% compounded quarterly for 5 years. But remember that N is representing time periods. So 5 times 4, so that we include all of the quarters in a year. Okay, so we're going to have our 25,000, 1 plus 7.4 over 1,200 to the power of 24, multiplied by 1 plus 7.9 over 400 to the power of 20. And then you can type that all into your calculator and you can get one accurate answer. So after 7 years, Melissa is going to have 42,844 Rand and 25 cents in the account. Okay, so that's what it looks like when we change interest rates. Let's see what happens when we start to add or subtract money along the journey. Bontling received 300,000 Rand as a gift from her grandfather. She invests it with the bank at a rate of 9% per annum compounded monthly. After 2 years, she withdraws 120,000 Rand to buy a car. 3 years later, she withdraws again 15,000 Rand to furnish her apartment. 2 years later, Bontling considers buying a small apartment of her own. How much can she spend? So basically, they're again asking us how much money is in the account at the end of this investment. Okay, but a lot is happening. So we definitely need a timeline to be able to picture how this is going to unfold. All right, so at T0, Bontling is investing the 300,000 Rand that her grandfather gave her. Okay, and we need to figure out how much time is going to pass. So let's see, everything that has to do with years. Okay, so she invests it. After 2 years, she withdraws. 3 years later, she withdraws. And then 2 years after that. Okay, so we're going to have a T2 over here, where she's going to withdraw some money. Then 3 years after that, so 1, 2, 3 years after that, we're going to end up at T5. She's going to withdraw some more money. And then 2 years later, this is not very well spaced out, but you get what I mean. T7, again, Bontling is going to consider buying that apartment. Okay, so let's figure out what's happening at each of these pit stops. Here we are subtracting money at T2. She withdraws 120,000 Rand to buy a car. And then 3 years later, she's going to withdraw again, minus 15,000 Rand. Sorry, those need to be minuses. Okay, and then we want to know how much does she have at the end of the day. What I'm noticing here, which is lucky for us, is that we've got one interest rate throughout this question. So we've got from T0 all the way to T7, the interest rate is staying the same, 9% per annum compounded monthly. So there we have it. And now we can get to answering this question. So A is equal to P, the present value, 300,000 Rand, 1 plus the interest rate, 9 over 1,200. For how long? Oh, we haven't filled that in on our timeline yet. Okay. Here we've got 2 years. We can even do the calculations here so long because it's all monthly. So 2 times 12 is 24. In this part here, we've got 3 years, so 3 times 12 is 36. And then finally, another 2 years there, so 2 times 12 is 24. Okay, that just helps us now to answer the question. So 24 months. Then we are going to subtract 120,000 Rand. Okay, and so now this, what has gone before, becomes the new present value. So be careful there. These questions require brackets, and we need to make sure we have enough brackets. Okay, 1 plus, we've still got the 9% there for 36 months before she withdraws again, 15,000 Rand. And now all of what's gone before needs to be bracketed in because it becomes the new present value for the final stretch of the investment where the interest rate remains the same for 24 more months. Okay, and then carefully type that into your calculator and check, are you getting the same answer as what I am getting? So if Bontling does all of this that she's planning to do, at the end of 7 years, she'll have 356,132 Rand and 66 cents to be able to buy an apartment. Realistically, she'd probably just be putting down a deposit, depending on which area she's planning to move to. But something to note before we move on to the next example is that there are always 2 decimal places when you are working with financial maths. So rands and cents, so that's why I rounded off the final answer there to the 2 decimal digits. Now here's a question to really get you thinking. You take out a loan to help fund an overseas trip. 4 years after taking the loan, you make an additional payment of 5,000 Rand. 2 years later, you repay the final amount of 6,000 Rand. The initial interest rate is 14% per annum, compounded semi-annually. After 4 years, the rate changes to 11% per annum, compounded quarterly. How much did you initially borrow? Now, you can do this as a normal timeline and just work out the equation to solve for P. But that's what I'm hoping you notice here, is that we are looking for what we initially borrowed. Okay, so if you are solving for A, then you can use the formula A equals P 1 plus I to the N. But in this instance, we are solving for P, and it's actually easier to use a negative N. Okay, so like I said, you can use this formula and it'll work as long as you solve your equation properly. But if you're solving for P, it's easier to say A equals P 1 plus I to the power of minus N, because you're technically going to work backwards to figure out what happened at the beginning of this thing that you borrowed. So here's our timeline. At T0, we are going to borrow some money. Then 4 years later, we are going to, so that's T4 there, we are going to pay back some of that money, so 5,000 Rand. And then finally, we're going to be done with this loan here at T6 when we pay the last 6,000 Rand. Okay, then we just got to get our interest rate in. So interest rate here for the first 4 years was 14% per annum, compounded semi-annually. So 200 there for percent, okay, semi, twice a year. And then it changes to 11% compounded quarterly for the remainder of that. And then let's just work out how many time periods there are. So here we've got 4 years multiplied by semi-annual, so 8 time periods there. And over here we've got 2 years multiplied by quarters, so 8 quarters over there. So when I'm calculating, a lot is going to happen here at this 4-year mark. Now to solve this, I'm going to work backwards. So P is equal to, we are going to start with that 6,000 that we paid back right at the end. Okay, and then we're going to work this way. So 6,000, then the interest there, 1 plus 11 over 400 to the minus 8, because I'm working towards finding P. Okay, let's calculate that. All right, so we've done that and that. Now, this 5,000 Rand was added to it. Okay, because technically if we paid it off, then we were owing 4,829. Have a look at how I haven't lost any decimal places, right? So I'm going to keep this answer on my calculator. I'm going to add the 5,000, because before I made that payment, then I would have owed 9,829 Rand. And that's then going to help me with the next step. So I'm going to say P is equal to 9,829 Rand, comma, 438,122. And the interest rate there was the 14% compounded semi-annually for 8 time periods, minus 8, because I'm still working backwards here. So let's do that. Multiplied by the bracket, 1 plus 14 over 200 to the power of minus 8. Gives us an answer there of 5,720 Rand and 82 cents. Okay, so that gives us the amount that we borrowed there at the end of the day. But important to note that if you are borrowing money, the amount that you borrow, in a sense, is still growing, because they're still charging you interest. So just to be careful with your understanding there, that's why we borrowed something like 5,720 Rand, but we had to pay off this 5,000 plus that 6,000. So we ended up paying 11,000 for this loan. But it really is helpful if you are not given the initial value. It's helpful to think about it this way and work from back to front so that you can get to that initial answer. If that throws you, then you're welcome to say P, use this interest rate to the power of 8 plus 5,000. Use all of that as your new present value and keep on going. And then you just solve for it algebraically. As long as your algebra is good, you'll be able to solve it. So it's always nice in maths to have more than one option, and when it comes to timelines, that is definitely the case.